Okay, did y'all enjoy your week off? Sorta, you didn't really have a week off. Let's see. I don't know if you saw on Canvas, I did get a field trip set up. And it's going to be Wednesday, November 20th. I already have all of your forms, so the field trip will be during class time, but we're going to meet out on the island at some construction sites and just walk through them. So you'll need to be out there at 9, and then we'll return here, and you have to provide your own transportation. Del Mar cannot provide transportation. So if y'all want to carpool or set up.
What day is that?
It's Wednesday, November 20th.
Okay.
I put it on Canvas so you can check it there. We will have what I call a field report, which I'll give you all that information beforehand. So you'll have to look for certain things while we're there so that you're not just, staring at the stars or whatever. But, so there'll be more information on that, but just mark your calendars that Wednesday, November 20th, we do have a field trip. And it's for both the online students and the in-class students. Is Frankie here? Frankie Martinez? No? Okay. All right. Well, today we're going to talk about roofs, roofing, and then Wednesday we have our next exam, which y'all can take in class. And so it'll be open book, so be sure and bring your book, just like all the others. It'll be over chapters 13 through 16. And then we'll have 2 more exams before the end of the year and the final project. So on to chapter 16, and then if you have any questions, if we have time at the end on your exam review, I'll try to answer those. Can everybody see the screen on their computer? Basically, there's 2 types of roofs, low slope and then regular high slope, I guess you would call them. Low slope is what you may call a flat roof. It's anything that is less than a 2 and 12. That terminology means the rise. You go over 12 inches, up 2 inches, just like the stair terminology. So anything that rises less than 2 inches and 12 inches is a low slope roof. And that's how you determine it, that's how you show it on your drawings, is 2:12. 2 inches for every 12 inches. Every roof has to have a slope, obviously, or it will just become a swimming pool if there's edges around it. So there's really no such thing as a flat roof. There's just low slope and then steep slope. The roof deck is what goes on first. That provides the structure for the deck, or for the roof. It can be made of different things: wood, concrete, etc. This one here is wood. Here's one that's going to have corrugated steel over some open web joist. The deck itself must be strong and stiff, and you can see through these diagrams what might happen. You have to consider the weight of the roofing materials. Standing water, if you're in the north, you have to consider snow weight. Y'all have seen on the news every now and then about Walmart's collapsing with the weight of the snow, because sometimes you can't predict one in 100-year storm, but typically the engineers are supposed to know what the roof can hold. Also, there's other circumstances. If the roof is not drained properly, the snow can't melt and drain out, so there may be a clogged drain, and then it just keeps building up and up and up. So that's something that is a maintenance issue. Here's some diagrams of different slopes. You got just a sloped structure. You can see that the structure itself, the columns in this case, are different heights, so that creates a sloped structure. You have a tapered structure where the building is flat, but the roof is tapered. And then you can also do with tapered insulation. That's mean, you know, the insulation you put up there goes from higher to lower. The roof deck should be smooth, not to cause distress or tears, etc. This is a substrate board fastened with screws with oversized washers. That's what these big round discs are. You don't want to just pound nails in it, or that would cause leaks, so you need these oversized washers to distribute the pressure and then also seal it up. Roof ventilation is very important, and where you put it makes a difference depending on what type of roof system you have. In this situation, you've got the vapor retarder. Just like walls, you'll want that to be on the warm side, so it depends what your climate is. You got your vapor retarder, then you have some insulation, then you got a little bit of ventilation to keep the mold and mildew out. Then you got your roof deck, and then you got a membrane. Here you've got insulation below the deck. You can see up through here. There's the roof deck, and you got your joist, and then you got this insulation bats laying in there. They're not that thick. You can see right here that there's quite a bit of space above them. Here you have this is when you use the foam. We looked at foam insulation a while back. That's just sprayed right up in there to get into all the crevices. So in this case, you don't have the vapor retarder on this side. Here you have the insulation above the roof deck, and this is where you would use like a styrofoam or some sort of rigid insulation on top of your roof deck. You don't do this when you're going to have a lot of walking up there, because obviously you can damage the insulation. So this is really only used in roofs that don't see a lot of action, I guess. Most roofs are that way, but you have to make sure that you provide walking areas to get to the equipment if you put this kind of insulation up there. This is something that can happen when you put the insulation between the deck and the roof. If you don't do it properly, it can cause bubbles and leaks and all kinds of bad stuff. Here's a detail that you could draw for extra credit. I haven't gotten a lot of those, and I know a lot of you need them, so better start getting together on that. Here you got a metal roof decking with a lightweight concrete. Here you have built-up roofing, and then the flashing goes between some of the layers, and then you've got this roof vent or equipment there, and that has to be 6 inches up. You can also do that with a rigid insulation. That's what they're showing here. You just got your metal decking with the rigid insulation, then you got your built-up roofing, and see how you got 3 layers there. Then you've got the lip of whatever your roof equipment is, your vent or your pipe. Then you come back on top of that with more layers of built-up roofing, and that seals it. Here's a picture of some roof insulation. Rigid board. On top of that, you are showing the aggregate. That provides protection from the UV and also a little bit of, little protection from wear and tear from walking on it if you need to. Here's some thicker insulation on top of the metal decking. We saw that picture a minute ago with the metal decking and then the styrofoam insulation. Then they come over it with some sort of either vinyl, EPDM. There's different things they could use here for this covering, and this one that looks like an EPDM covering, which is like an elastomeric membrane. You can also do lightweight concrete that's up to 7 times lighter than conventional concrete, and you can slope that as required. We're going to do a little exercise on roof slopes in a little bit, but you can see obviously how it is sloped to wherever the drain is going to be, so they can force the water where it needs to go. Just more rigid insulation. Here they're talking about the vapor retarders. The red line shows where it is on these two different walls, or the wall and the roof. And this describes, I mean, y'all need to go back and read these slides, obviously. They're on Canvas. I'm not going to read them to you. I'm just hitting the high points. This is all the different types of membranes for low slope roof. You've got 3 basic types. You've got bituminous, single ply, and fluid apply. Bituminous is built up, can be asphalt or coal tar. Single ply is more the elastomeric, which that white sheet in a few slides back we were talking about. They can put that on top of the roof membrane, and that can come in many colors. It's also very green, or it reflects the light and makes a very cool roof. Cool meaning it doesn't, like black tar roofs get very hot. A cool roof will reflect and keep the building cooler inside. And then you got fluid applied over here, which is the 3rd type. And so this just kind of goes through all the different, I'm not going to read it to you, but you should go back and read up on it if you haven't already. Here you can see a demonstration of the built-up roof, how it works. You've got sheets of roofing felt, and they're all overlapping. So in any given point, in this case, there's going to be 2 layers, because you can see there's going to be 2 here, and then 2 there, and 2 there. And then they can come back and do it all over again, and then they hot mop this tar stuff on top of it to give it a good seal. Here's a diagram of how it can add up in the layers. So in this situation right here, you've got a 1, 2, 3, a 4-ply roof, because it's at any point there's going to be 4 layers of that tar or the felt. Here they're showing the crushed rock, and then on the bottom they have a liquid coating. You have to this is the liquid coating that does its own reflecting, and it has its own UV protection. The rock in this case is what provides the UV protection from disintegrating anything that's below it, like the insulation or any other kind of coating. Talks more about the components of the built-up roof here. There's a guy installing it. Here's one, a modified bitumen roof. You know, it doesn't have to be this one has a white surface, so that's also very good reflective. Not going to read through all these. Single ply gets into that. And as I was saying earlier, you could have different colors of the single ply. So, you know, depending on your design, if it's going to be seen, you want, you know, you might want a bright color to add something to that. I mean, you can probably get any color in the rainbow now. Of course, you know, that also costs more money. Here they're putting that material on, and they've got the screws or the nails with the wide washers, and then this is going to come over it, and they're going to seal it. So hopefully no water will penetrate. Just some scientific information about how it sets. There's like an iron, that's what seals it. They run that across the edges. It's very hot, it blows hot air, and it makes a tight seal. EPDM, that's what I was talking about earlier, synthetic rubber. Sometimes you can get that, like if you have a roof deck and you want to walk on it, they make these where they're very durable and you can walk on that, you know, regularly. Single ply, obviously, you have to have more skilled craftsmen, because any mistake, there's only one layer, and you know if you get a leak in your roof, it can damage a whole lot of things in the building. So it's a more expensive membrane because it has to have more skill in its application, and there's less chance for error. but it's also probably a better if it's done correctly. Here's a fluid applied. You can see the guy spraying it on there. That's obviously a very cool roof because it'll reflect a lot, and the inside will stay cool in the summer. Here's a metal panel roofing. Now obviously when you do this kind of roof, your slope, even though this appears flat, there is some slope to it. Looks like it goes that way. Your slope has to go with your ridges. You can't have it going this way or the water will not slope downhill. So that's one design point you have to be careful about. Here they're putting it together with some clips. And this is just a graph showing you the different percentages of different types. Okay, we're going to have an exercise on this in a little bit, so pay attention. This is probably in the book too. I'm sure it is. So in the right, roof slopes and drain locations are arranged to ensure positive drainage through the roof surface. So you can see here, this is a roof plan. This is how you would draw a roof plan. And you have, these are your drains right here. You got 2 drains. So you obviously want everything to slope to a drain. So this is what we call a valley right here. And then, so this is gonna be higher over here. It's gonna slope down to that drain. It's gonna be higher over here. It's gonna slope down. Same thing, same thing. But what do you do in this area? You gotta make a cricket. That's what it's called right here. A locally sloped surface used to divert water around obstructions in the roof or create a slope in level areas. If you didn't have this cricket, you would get a big pond right here. So they build it up and they make a little ridge right there and they slope it that way and that way. So it says, note how at a slope of 1/4 inch per foot, the roof surface rises 6 1/4 inches over the 25-foot distance. 25 feet times 0.25 inches per foot equals 6.25 inches. So they wanted you to figure that out. If your drain is here and you're sloping 1/4 inch per foot, then the edge of this roof is going to be at 6 1/4 inches. And you typically want, the rim of your roof to be all the same. It would look weird from the outside if it was like going all, different heights. So you'll probably take the highest point. You figure out where your drain is furthest away from the edge, and then go back up to the edge, and that will be the height of your roof all the way around. This is a kind of an L shape, so they're going to have a ridge here, that's the high point, and then they're going to slope down again to this drain. There's only one drain here. So it says here there's a cricket behind the rooftop equipment, so this is some sort of air conditioner or something up here, or it could be a chimney. So they built a little cricket, they built it up there, and then they slope down, and then the water diverts. Does anybody have any questions on that? Do you understand what it's doing? Can you see it in your head? Yes? Got it? Kinda? What's your question? Uh-huh. This right here? It's because this is called the cricket again. These drains are at the same low point. If this wasn't here, it would just be a flat space and water would pond. So this is a built up area. They built it up, and now this is a high point right here. They've sloped and sloped. It'll look, you get it? I'll just make, like you're sloping down, you got your drain right there, drain right there. That's kind of what it looks like in section. So what they did was they just built up a little bit. So now you got water going that way and that way. Any other questions? Okay. Obviously, this is you got a drain. This is a big, I spent a lot of my early years detailing this stuff because you always got to make sure it's detailed right. My boss said that you got to pretend that the contractor knows nothing. So you got to make sure that you've shown everything you want to show so that there's no excuses for them to build it wrong. Hope none of y'all are contractors. But here you can see you've got your roof, decking, you've got your insulation, then you've got your built up membranes, then you're going to have a gutter here. So the that gutter comes up and it's going to come, this is the metal angle that keeps it there, and then you're going to put more membrane on top of that. So the idea is the water has no place to go but down into this gutter. It won't come back this way. And then on top of that they have their aggregate. So here's a roof curb. A lot of times, you know, you look at buildings and you'll see just a wall that's, you know, behind it you've got this curb because there is a roof with a slope behind there. So you got your wall coming up. In fact, this roof is probably the same way. You got your concrete block and your brick, and then you've got your roof cap, all that stuff. And so in order to keep the water from, you know, seeping down into the building through this edge, you're going to have a cant strip, which is just a little triangle piece of insulation or wood. You're going to run your built up membrane up that. Then you're going to come on top of it with this flashing right here. Oops, sorry. And then that's interlocked with that, and that goes on there, and blah, blah, blah. So if you got water on this roof, it's going to be very hard for that water to get up all the way up here and back, you know, seep down there. I'm not saying it never happens, but it's going to be a lot more difficult. Here's another roof drain. A lot of times you'll have a regular drain and then an overflow drain in case the regular drain gets clogged up with something or it freezes, you know, and because like I said, you really don't want the roofs to collapse from too much water or snow, so you have to build in some safety measures. And this is how they would flash the roof drain. Here's a good detail for you to copy sometime. Like I said, all these lectures are on Canvas in a PDF format, so you can just go to that slide and look at it. It's not just in the movie. But here you got the, you know, concrete wall, and then you got some flashing, and how it has a sealant, hot air weld, and all this stuff. That's a single ply roof, so you don't have the built up layers, but it still has to be detailed correctly. Just another detail for a low slope roof. Everything overlaps. You just imagine, you know, this has to overlap that because it'll be harder for the water to go uphill against gravity. So the water's going to tend to just go that way. And this, whoops, gosh, sorry. And this, you know, goes all the way under this, protecting the whole wall. Then you got stuff overlapping that. And you could even have some more if you needed it. So then we go to steep roofs, which are normally on houses or pitched roof. There's all kinds of materials you can put on steep roofs. Shingles were the original type, overlapping, staggered joints. Originally we used cedar shingles. They make treated cedar shingles now, but you know, the wood is such a fire hazard if it gets dry that it's probably better to use something else. But this is a tapered shingle, meaning that on the back edge where it's tucked under the shingles above, it's going to be a 1/4 inch, and it tapers to a 1/2 inch on the front edge where you see it. You got wood shakes, are thicker than shingles. These are terms you need to be familiar with when you're reading your chapter, so if there's a question on the test, you can go find out the answer pretty quickly, where this is at. A split face has a rougher texture than a sawn face because it's just split. Sawn obviously use a saw, and Makes a smoother finish. When you do wood shingles and shakes, you don't have necessarily a wood decking. You have this skip sheathing, and that's so that it can stay ventilated. And you want the wood to stay at an even moisture content so that it doesn't shrink and swell. Because if it shrinks and swells, it's going to cause damage and leaks and all kinds of stuff. Also, with wood shingles and any kind of shingle, you always start at the bottom with your first row, then you overlap, and then you overlap. And you do that, obviously, so that the water doesn't, when the water falls down the roof, it keeps going this way. It's not going to go up and under these shingles. Here's a breather mat, is what they call it. Allows the air circulation. So if it gets wet in there, it can dry out easily. You know, also depending on what material you use, how long you want it to last. You know, is the building only expected to be up to 10 years, you can use a cheaper material. But if it's going to be a long time building, you want to use something that'll last longer. Here's asphalt shingles, with something you're more familiar with on most houses around here. It appears that, you know, when you look at them, that you got 1, 2, 3 shingles, but it's a 3-foot long thing with tabs in it, and then they overlap those to give it that appearance of a bunch of different things. All different colors are becoming available, and styles. Again, you start from the bottom and you work up with your felt and with your shingles. Here's a picture of a valley. Valley is when the roofs come together like that. Hip is like that. So when you have a valley, which is usually at a corner of a house or where 2 walls meet together like that, you're going to have some flashing there. You're going to overlap all this stuff so that the water does not have any chance to go back up in there. This is another way to do it with the membrane behind it, and then you overlap the shingles. And this is a closed cut valley where these went all the way over here, and then these are cut. So nowadays, asphalt shingles can go 15 to 25 years, even some are 30 years. Minimum slope would be 4 and 12 to use asphalt shingles. That means you must go up 4 inches for every 12 inches at least. Here's just a mineral surface roll. This can actually be done like on a very low slope because it's not much nothing to get in the way of the water. It's very smooth. And you might do this on a porch extension or something like that you didn't have much room to slope. Slate, which is a form of rock. These last a very long time, but at the same time they're also very heavy, so you have to beef up your structure to hold them up. Minimum slope is 4 and 12. Then you got your clay and your concrete tile, again very heavy, lasts longer, but it's heavy and you have to beef up the structure to hold it up. These are some aluminum shingles on here, and then copper down here. That would be very expensive. You use it on special things, like little steeples, stuff like that. You can have the copper shingles, or you can have sheet metal or sheet copper that would patina and turn the greenish color once it ages. Architectural sheet metal roofing, which is just rolled pieces of aluminum or steel that is zinc coated. That's what it kind of looks like. Flat seam metal roofing, which is it gives a flat appearance. You can see the seam detail here. You have one piece, then you interlock it like that. Then you have another piece going over it to make sure nothing gets down in this little nail area. Here's a picture of a flat seam roof. That looks very labor intensive. I don't think I've ever really seen the real one of those. Standing seam is something we see a little bit more often. It's, you know, the sheets of metal with a vertical seam. This is how they would put them together, you know, fold it down and crimp it so that nothing gets in there. That's a standing seam, copper. Batten seam, you would have a little board in there if you want that thicker look, and then you would put the little metal piece on top and fold it down. There's a batten. These are just the normal sheet metal panels, metal roof panels. You can get that in many, many colors now. They have this roll of the metal, whatever metal it is, up here on the truck, and then they roll it out and it forms the edges that you need to, so you can do this on the site and cut it to the exact length and then carry it up to the roof. Different thicknesses obviously affects the quality of the roof. You measure it by gauge. And it says, you know, note that you would think the higher the number the better, but in this case the higher gauge is a thinner sheet, so you'd want a lower number for a metal roof to last longer. Copper, that's how they express those thicknesses. And this is something not just in roofing but in all things you need to remember is the galvanic series of metals. When different metals come into contact, electrical current flows between them, and the corrosion of the more active anodic metal results. That means it's corrosive. You need to avoid direct contact between metals that are far apart on the galvanic series. So you could put zinc and aluminum pretty close together, like you could use an aluminum screw on a zinc roof. You might even get away with cadmium. But if you're doing something down here, if you have a material down here and you're trying to match it up here, you're going to have corrosion. And so you want to stay away from that. Sustainable roofing, obviously, can be green roofing, where you have the roof gardens or earth on top. Or it can just be roofs meeting, like I said, you know, with the EPDM or the liquid applied membranes that do a lot of reflection and don't allow the heat to get into the building. But also you don't want to create a heat island. You don't want to like have a giant reflecting pool on your roof that shoots sun into the skyscraper next door and like makes them bake. So you got to think of all the different, you know, when you're talking about green roofing, you want to be nice to everybody. Different colors make a difference. You can get some darker colors that have a reflective quality, but obviously the lighter the color, the more reflective it is. All of these are cool colors, and you may not think so, but if they're metal, they can reflect. There's obviously a garden roof. I would always be scared to do that. I just think it would leak like crazy. But again, you know, just like with the concrete tile or the clay tile, you got to really beef up your structure and make sure that it's all done right below this garden area, or you're going to have trouble down the road. These are the typical components it talks about. You got your plant material, you got your soil, you got a filter fabric, then you got a drainage mat, then you have rigid insulation down here. You got this area here where the water comes and it's got to drain off somewhere. Then you got rigid insulation and your waterproofing, etc. So, okay. So now let's see. I wanted to show you a quick, I want to show you a movie, and I want you to do this. So would you rather see the movie about green roof? It's a 10-minute movie first before we do this? Okay. Alrighty. Let me pause this. From that film, you can see he talked about all these different layers for their green roof, and then also the structure and stuff involved. Okay, now I'm going to hand you out the exercise for the low slope roof. We'll go over it a little bit. Okay, so it says on the roof plan to the right, add the arrows indicating slope. I'll go back to that slide. Second slideshow, current slide. Okay, go there. Well, it won't switch. Okay, hold on. Let's go this way. Okay, add arrows indicating the roof slope, like they did on this plan. These are the arrows. Assuming that the slope is 1/4 inch, which is 0.25 inches per foot, label the high points, like they did here. See, in this one they figured out it was 6 1/4 because they did 0.25 inches times the length from the drain to the edge. If the roof edge can rise as much as 16 inches above the drain level, you need to also figure out what is the maximum possible slope specified to the nearest 1/8 inch. So that's kind of a reverse problem. If this can be 16 inches higher than that, then what is the maximum slope? Then the one on the bottom, it says add the arrows again, like this. Assuming that the high point on the center of the cricket, which is on your page, the picture at the bottom, which looks similar to this, that's the high point of the central cricket, is 6.25 inches above the drain level. What is the slope of the cricket? So if that's 6.25 inches from there, and on your page that's 25 feet, you need to figure out what that slope is. Y'all can work together to figure this out. And then assuming that the remaining roof surfaces slope at 3/8 inch per foot, label the roof high points. And then modify the plan so that the slope of the cricket matches the typical slope of the roof. So start working through that, and you can ask me questions. And if you also have questions on the review, I will answer those. We'll work on this for the rest of the class time. Okay.